Hi, this is Tutor Buxton. Welcome to my channel where we get to learn construction and quantity surveying skills at large. Today I would like us to cover the estimation of slab. Over the past few sessions, we've had a privilege to be looking into preparation of bills of quantities, and so far so good. We have done up to reinforced concrete superstructure. For those who would like to catch up, please, you'll find the rest of the videos at the description part. For those who are continuing in this session, which is a preparation of bills of quantities, please welcome to the channel and let's continue. When you want to measure slab, it's normally done in square meters. So we are doing what we call the suspended slab. For this is a high-story building, and we have quite a number of floors, which are 5 of them, and I would like us to learn how to do the estimation for the suspended slab. The rule states that we need to measure the suspended slab in square meters, but then in what extent do you need to consider the coverage for that square meters? So those are one of the items that we'd like us to cover today. After the suspended slab, then I would like us to look into staircase, a bit of it. So the unit for measuring suspended slab is square meters. To the side of our Excel, this is where we'll be doing our calculation for us to assort that particular area for our slab. So looking into this plan, the one that we are using, normally I always like to approach my plans in reference to the grids, so that I make sure that whatever that is available in terms of the scope of coverage is well taken care of. So this plan, I believe it's well zoomed in and you are able to see it properly. I'm going to start from grid 1 going all the way to grid 10. So from what we have, looking at the dimensions, and then we are able also to tell from the dimensions how do they go, or where do they end. So for instance, this is grid A1 to grid H1. So all the way, when you look at this keenly, then you notice that what we have is along the centers of that grid. So that means we need to add the exterior parts, because the plan that the area that we're looking for should be covering from external faces of the wall. And in this case, what we have been shown is the layout of the beam, and the beam is straight onto the wall. So it means, covering the whole wall. So it means we need to cover, we need to do our area from the external faces of that particular wall. So looking at this, let's start. Let's do what we have to do here. Along the longer grid, it's from grid 10, and the second grid 10, that is, to grid 1. So I just want us to add, actually there is one that is provided, and it's along the centers, giving us 12.4. Okay, so what we do, we add. So this is, we just indicate here, area for slab. So for our area of the slab, then equal sign, so that we make our calculations here. This is 12.4, and the 12.4 is along the centers, because we need the area of the slab along on the external faces of the beam. So 12.4, and then we add 0.1, because the wall is 200, half of it is 0.1, therefore, all right. And then it's therefore 0.1, then we multiply by 2, so that we get those external faces of the beam to the exterior parts, so that we reach to the external faces. So we get 12.6, and then when we get to the width, it's 9.2, and then we also add another 0.2. Okay. Alright, so the 9.2 is on the centers of that particular point. So that is 9.2, and then we add 0.1 times 2. Okay, so that gives us 0.4. So once we have that, we'll take it full, we'll take it complete, or what we have here. We multiply this, basically this now the length and then we multiply by the width. So having done that, then we need to measure the area net, implying that we take it complete and then we are able to subtract those areas which are not forming the slab, okay, or those areas that are going to be considered differently from the slab, okay, and then we multiply by the number of floors which are typical to the one that we've just done. So that is the best approach that we can always take to measure our slab. So we'll subtract, okay, we'll subtract the part of it which is not the slab, and that include the stairwell. So we have into bracket. So there are those areas that we need to subtract. First of all, when you look at from grid A1 to B1, actually midway, A1 to midway between A1 and B, there is that portion there which is included but is not slab. So that is one of the areas that we need to adjust by subtracting from the main slab, okay. So the length of it is going to be, we need to add, we can take it all the way from grid 5 all the way to grid 1, okay. So that means let's see what we have. This is let's just have our Excel so that we do our adjustment while at it. So first of all, we have this is 1.2 plus 1.1, okay, that gives us 2.3. 2.3 plus 2.1 is 4.4. 4.4 plus 0.6, that is 5, okay. 5 going along the center still, so it means, but we need it pushed in the extent that we need it beyond the slightly beyond the wall where the grid 5 is, out of it. So it means we'll be subtracting 0.1 from the 5 there, and then we add a 0.1 to the bottom, that is the bottom of grid 1, because we also need it to the outside face of that particular beam beyond grid 1, okay. So that means it's minus 0.1 plus 0.1, so that is the length maintains to be 5, okay. And then we multiply by the width. So what is the width of that particular point? You can see here that particular length is not indicated, but from our previous work we had confirmed that it's 0.6. that is from the architectural plan. So I'd just like to emphasize that whenever you find that there's some dimensions that are not shown on the structural plan, then you need to reference them from the architectural plan. So we did so in our previous session because this is a plan that we had done before, and it was coming to 0.6 along the centers, okay. So this 0.6, just the same way we've reasoned out for the length, we are going to add 0.1, okay, to get to the external face, and add another 0.1. So we subtract 0.1 minus, now we subtract 0.1 and then we add another 0.1, so it still remains to be 0.6. So in that case, that is what needs to be subtracted. So that said, we also move along. So we started from this corner going all the way, and whatever is here, let's see if it's similar. These are 1200 and then this is 3200, that gives us 4400 plus 0.6, so that's another 5 meters. So the dimension that we've dealt with down here, okay, is similar to the dimensions that we're dealing with to the top, okay. So it means what we have, the 0.5 times 0.6 we multiply by 2, okay, and then we also, we multiply by 2, so to the top and to the bottom. Then there is another part here. There is another part between the columns, that is grid, let's see, that is grid C1 and E1. There is another portion that is to that point, so we also need to deal with that as well. So looking at it, we have a longer side coming from 700 to 1100, okay, that gives us a total of 1800. But then 1800 is to the centers of the beams, so we need to subtract 0.1 times 2, okay. So from the 1800 we remain with we remain with 1600. Okay, so that gives us 1.6, and then we multiply by 0.6, because the 0.6, it's minus 0.1, which is the side of the beam, and then we also add another 0.1. Okay, so we take that, so this is another 0.6, and then just want to confirm if it's similar to what we have to the top. And it's similar because the grids that are leading us to the, just zoom it out again, the grids that are leading us to what we found to the bottom, that is towards long grid 1, is similar. They are the same grids to grid that portion to the top. So we'll multiply by that. We'll multiply that by another 2, and then let's see what else to adjust from it. And that gives us to the end. But then we also have the stairwell. Stairwell also needs to be subtracted from that area, and then when you're subtracting the stairwell, you subtract it from the internal faces of the beam that are demarcating that particular stairwell. Okay, so what we'll do when we are here, it's is this. So what we do here, this is 3.2, yeah, because the stairwell is from yeah, you can see there is another beam here that is along grid B1, and it goes all the way to grid D1. Okay, so it's B1 to D1. So this is what we need to deal with. So what is here? Let's see, D1, yeah, D1 to B1. So it's 1100 plus 3200. So those are the dimensions we need to add, so that we get the length that are for the stairwell. Okay, so let's do that. Actually, looking at this staircase or the stairwell, it's ending at grid A1. Okay, it's not ending at grid B1. Therefore, we need to take it completely from A1 all the way to grid D1. Okay, because where we have the steps is the one that I've just referred to, that is B1 to C1. Okay, but then there are other parts that are going beyond that, especially to the landings on both sides. Okay, so we take A1 to D1. Let's add those dimensions and we get the length. So what we do, all right, A1, so it's 1200 plus 3200 plus 1100, so that is 4300 plus 1200 should give us 5500. So 5500, just zoom it in again. So 5500, and then we subtract, because we don't only take it within those particular beams. Okay, so that means it's 5500 minus 200, so that gives us 5300. So it's 5.3 times. Let's see what else to include. This is now from grid 5 to grid 7. Grid 5 to grid 7. Let's see what it gives us. This is 1200 times 2, but then we also need to subtract 200. That is 0.1 on one side and 0.1 to the other side. So that is 2.4 minus 0.2 gives us 2.2. Okay, so this is 2.2. Alright, so I believe all the adjustments are taken care of, the areas that need subtracted, and also the stairwell, so that we are able to find our area net in terms of the slab. So this gives us an area of 98.86 for one floor. Okay, But then when you read here to the detail, you can see very well that it's shown typical floor slab details from first to fourth floor. Okay, 150 millimeters solid slab unless otherwise shown. Okay, so yeah, that is for the first floor to the fourth floor. Okay, so we can get to the plan, we can get to the sections where it's been shown. For instance, a section of the columns, so that we are able to see how many slabs are there from first to fourth. Okay, so that we don't second guess in terms of the items. So from here, this is a ground floor. All right, so that is showing us from first to fourth. Okay, of course, for ground floor, the slab for the ground floor is what we covered under the substructures. So when we talk about first floor, it's now the floor where the first floor is located. So that is the very first one. Okay, when I zoom it in, you are able to see. So this is 1, 2, 2 for the second floor, 3 and 4. Okay, 4 is for the fourth floor. Okay, so we need to see. Yeah, so those are 1, 2, 3, 4. Okay, those are 4 number slabs, that is from first floor to fourth floor. Okay, so once we've counted that, so these should be multiplied by is equals to this is equals to the 98, and then we multiply by 4. Okay, so of course you can decide to assort your slabs in terms of just measuring them on every floor, but for these types of the summarized bill of quantity that we are doing, we are adding them all together. So for the 4 floors, we assort them together, and then now there is another slab. Okay, so it means in this case we can have suspended slab, but then of course include the thickness 100 millimeters thick suspended slab. Okay, in case you are not sure about that, then you can go to the slab that we've just measured and confirm if it's really 150. Okay, it's indicated as 150 millimeters solid slab unless otherwise shown. So this is 150 millimeters. So what we have is 150 millimeters thick suspended slab. Okay, suspended slab, you can put in bracket or just put it as a full description. First to fourth floor. Okay, first to fourth floor. So once we have that indicated, and then we have got the area for those from first to fourth, and the area is 396. So we have this as 396 square meters. But then that is not all, because when you look at the section of the column from the column level, then you notice that we still have other floors, and those floors include we still have, let's go to the columns. So we've done up to the fourth floor. Okay, we still have from the fourth floor, we have the column, the slab for the fifth floor, and also we also have another slab for the roof floor. So we still have like 2 more slabs to measure. So let's go to the fifth floor plan and see what we have. Alright, so we are here. This is another one, and this is a roof slab and a beam layout. Okay, so this is the roof slab. Alright, so this is the roof slab that we are talking about, and these are the roof slab details. So just the same way we've handled the other one, we also need to handle this one the same with the same approach. Okay, this being a roof slab, you notice that it's going to be it's extending beyond the beam, or beyond the external face of the beams, the way we've unlike the one that we've just handled. Okay, so that brings that difference. So it means in this case we need to add that overlap beyond the beams so that we measure this particular slab. So looking at it from grid A1 to H1, what we have, the dimensions are going to remain the same. I can see this is 9.2, but then on either side of the extensions we need to see how long it's extending beyond that. Okay, so looking at this, I can't see that dimension unless, let me see from the beam side or the beam layout, if at all it's indicated. Doesn't seem to be there as well. So in that case, you need to consult the architectural drawing. Whenever you find that there are dimensions which are not shown from the plan of the structural drawing, then you need to check with your architectural drawing to confirm and see what to add for the overlap. Okay, so let's look into that. So let's get to our architectural plan. I believe it's this one. Yes, this is the architectural plan. This is a typical first to fourth. We don't have the fifth floor. Let me just get it right away. So looking at the section, so that we see what the extension is, and from here I can notice that it's 750. Okay, so the 750 is what goes beyond the wall that is shown on the structural plan. Okay, so let's get back to that plan, and from here this is what we can see. This is what you can see. So let's get back to it. So from this point, using the grids that we had done previously, that is from 9.2, so beyond it, it's 750 to the external face of that particular point. Okay, so we need to take 9.2 and then we add the extensions 750 from it, and 750, if I can just get back to the section again, the section is here. If I can get to this section again just to confirm, you can notice that from what we have here, the 750 is from the external face of the wall, not from the center, as the structural plan has been indicated. So it means from the structural plan, then we'll need to add the 0.1 so that we get to the external face of the wall, and then we also add another 750 to get that extension beyond the wall. Okay, so having noted that, let's just get back to it. So this is for instance, this is 9.2. For the 9.2, we'll need to add 0.1. okay, because let me just zoom it again. 0.1 is this point, the external face, another portion of that beam to the external, so that we get to the external face of it, and then from there, then we'll add the 750 to get to the external face of the extension of that particular slab, and then that will be done twice. Okay, so we can copy this. Once we copy that, we just paste it here. This is now 150 millimeters thick. Okay, let's confirm the thickness. This is also 150. So we can put 150 millimeters thick suspended slab, or we can talk about suspended roof slab. This is now for the fifth. This is now for the fifth floor. Okay, of course we'll get the area and then we fill in there. So before we get to that, let's just indicate here roof slab, and then we calculate the one for the roof slab. So so far what we've seen, it's for instance this is 12.4, and the 12.4 is up to the centers of the external beams. Okay, So we'll take the 12.4 and then we add 0.1, which is half of that beam or equivalent to the thickness of the wall. Then we multiply by 2. Okay, then we'll add 0.75 also times 2. So the 0.1 at first is for us to get the external face of the beam indicated here on either sides, on both sides. And then the 750 is from what is from the external face of that beam to the edge of the extension. So 0.75 times 2 for the length. And then we calculate for the width, and at the width is 9.2. You can see 9.2, and then we add the same dimensions that we've added for the one that we've just done for the length. Okay, so this is 9.2, and then we add 0.1 times 2. Okay, and then we add 0.75 times another 2. 0.75, that is now the extension. The very similar explanation that we've given when we are handling the one that we've just done. Okay, so that width is 10.9. So we'll take that this for the length, and then we multiply by the length by the width, and then we subtract. Now I would like us to subtract what we've done. We'd like us to subtract the portions that needs to be subtracted, those that are not part of the slab. Okay, and that include, okay, you remember we did the 9.2, and the 9.2 we did was going up to the external faces of the extension. So it means the very similar items that we subtracted while doing with the slab for the first floor are going to be subtracted here as well. That includes this portion here where my cursor is indicating, and also the portion for the staircase well. Okay, so having noted that, this portion is going to remain the same. Okay, because whatever was added, the 750 that was added, it was added across from all with all the including all the extensions that we've covered. So it's like adding one and then subtracting one. So looking at this is remaining to be 0.6, and then what we added was 600, 2100, and also 1100. This was giving us 27. That was 3800. Yeah, this is also still 5. 3800 plus 1200 giving us 5 meters. Okay, so for the 5 meters, we'll subtract the portion that we have for the extension here, and then we'll add it to this other portion, to the external part. So it means it's basically plus 1 minus 1. So the items that we added and subtracted for the previous part are going to remain the same. Okay, so let me just refer to what we have, what we did here. And what we did here, it was 5 times 0.6 times 2, and then we also subtracted 1.6 times 0.6 times 2, and then yeah, that was now these are smaller parts here indicated, the areas at those are the areas within grid C1 and E1. So they are going to remain the same for adjustment. And then the 5.3 times 2.2 was on this for the stairwell. So we'll just add, we'll just copy that. After copying that, and then we adjust it for this one here, we subtract. So when we subtract that and then we copy, let's just copy what we have, copy it here, and of course we have to bracket it so that all of them are mathematically correct without an error. So that is what we get for the 5th floor slab, 135. So we indicate here the quantity 135 square meters. Yeah, so looking at this, there is still one more thing that is left. So this actually is D. There is still one more item that is left, because you realize our plan, what we are dealing with, has got what we call the upper floor, the roof, another roof floor. Apart from the 5th floor, there's another roof floor. Okay, so you can confirm from the column section if at all that is existing. So looking at this is where it is. So what we've done is for the 5th floor. Apart from the 5th floor, there is also another roof floor. Okay, there is another roof floor that is going beyond the 5th floor. So actually you can also indicate this 5th floor. Then now item E, we also have this. Now item E, 150 millimeters thick. Let's confirm if that is the thickness. So we'll just go straight to straight to the details, if at all it's where it's indicated. This is the one that we've just done for the roof slab. There is another one here. What is called now? It's called water tank slab over the staircase, and this is a grid A1 to G1, and then grid 4 to 8. So this is the one, but this is for the beam layout. There is a part where the slab layout has been indicated. So for the slab layout, this is where it is. Okay, and the extensions are similar to what we've just dealt with for the 5th floor slab. So let's look at this and also measure it. I've came also to confirm the thickness. The thickness is now different, 175 millimeters. So that is how different they can be, and if you're told you're not keen about them, then you might have wrong descriptions. So you always keep confirming what you have in each and every step. So this is 175 millimeters thick suspended water tank slab. So I think that is the right description. So this is a suspended water tank slab. Okay, so that is what we have, and this is called roof slab. It's shown there. All right, so let's get to calculation of the quantity. So from here, it's from grid A1 to grid H1. Okay, so let's add these items here. So this is 9.2, and looking at 9.2 is including all the way. Let me just zoom it in again. 9.2 is including all the way from the external faces of this particular slab. It's from external face 1 and then to the external face of the other one. Now this one doesn't seem to be externally, so we need to add a part of this. Let me zoom it in so that I can see it as well. Yeah, we'll need to add part of this wall to the external part. Alright, so if that is not very clear, we can confirm from the section. Again. Yes, so you can see from one of the faces, that is now a long grid D to F, that part it's 1250 millimeters, while on the other side it's maintained to be 750. That is from A to B. Okay, so DF is having an extension of 1250 and the other one is 750. So let's get to our structural plan and finish it up. So the other one is D. Oh, actually I've confirmed with a different section. It should be, yeah, it should be this one. Yeah, because you know there are two blocks. So the block that we're dealing with is here, and these ones seem to be similar. Yeah, this one seems to be similar all through. There is no longer side, so all of them are 750 on each side. Alright, so that is that being similar. Let's get to this. So we'll take the 9.2. Of course, this side looks to be from the external part, but on grid this is grid on grid A1, it's not to the external face, so we'll need to add 0.1 for that beam to the external part. Okay. Alright, so let's get, of course this one is not yet filled because we need to do it. So this is a water tank. This is the water tank slab. So is equals to, so it's 9.2, but then we need to add now 0.1 for the external part of this this beam that is along grid beyond grid A1. Okay, so we have that, and then now for the width now is going to be this is 6402, and 6402 isn't including the external extension, which is 803. Okay, but it's including to the lower side. Actually, it's including the 803, so that is well included. So this one includes everything. So 6402. All right, so this is 6.402. 6.402. So this is 9.3. We multiply by that, we get 59 square meters. But then there are those portions that we need to subtract. One to the lower part, that is where grid 4 is passing through, and also where grid 8 is passing through. So we need to take care of those two areas. And that said, we need to subtract now. Alright, so this is 3200 plus 1200, and then we add the 0.1, but then subtract the extension on this portion here. So which basically it's minus 1 plus 1. That's the same way we are subtracting the other one. So it's 3200 plus 1200 gives us 4400. Okay, so 4400 will subtract the 750 of extension just on one side. Okay, we won't subtract this 0.1 and add 0.1 because it's going to cancel out. Instead, we'll have 4400 minus 750. Okay, so that gives us a difference of 3650 for the length, and then the extension is going to be this is 799, but then it's including, let's see the other portion. This is 799, and then the other one is 600. Yeah, so it's 799, but then we need to add, there is another part just above grid 4, and that is 600 from the previous dimension that we had worked with. Alright, so that is 799 plus 600 should give us 1399, but then on the length it's going to remain to be 3200. Actually, that one we had calculated. Let's see. Right, so this is subtract. We are going to subtract now. Yeah, so that is 3.65. Then we multiply by 1.399. Okay, for the width, and then this should be multiplied by 2, the bottom side and the top side, which are sharing the same dimensions. Let's see into this. Actually, the other one is 803. The other one is 803 plus 600. So the other one is slightly bigger, but then we can take that difference is about 4 millimeters, so we can use the smaller one and then multiply by 2 without any harm. But alternatively, you can take the 803, then you add 600, and then you consider the other one as a different with a different dimension. So let's see if at all there is any other point that is remaining, and I can't see. So that is all concerning that particular area. So this is 50 square meter for the area. This is 50 square meters. That gives us to what we calculate in terms of a suspended water slab for the slab. So that is it. That is what we intended to cover today. Basically just suspended slabs, and then await our next session where we are intending to go over staircases as well. So that brings us to the end of our session today, and I want to say thank you so much, and I hope that it's been worthwhile to go through it together. Until we meet again in our next session, please subscribe before you leave the platform so that you don't miss any of our subsequent discussions. Thank you very much. Have a great time till we meet again. Bye bye.